In this video, we will solve the questions asked in the Madhya Pradesh Public Service Examination for the Assistant Professor in Economics held in 2025. The first question is if the demand function is, that is PD is equal to 3x square minus 20x plus 5, where x is the output, P is the price, and supply function is PS is equal to 15 plus 9x. We are supposed to find out the producer surplus. Options are being given. We need to find out the correct option. So we have the demand function and supply function. If I draw a simple graph here to make the things clear, so if I draw it like this, we have the quantity on the horizontal axis, which is denoted by x, and price on the vertical axis. We have a non-linear demand function here. Okay, so let us suppose we have this kind of demand function. Okay, this is our PD, and we have the supply function as 15 plus 9x, which is upward sloping supply function. Okay, let us say this is our rather PS, which is the supply function. We are supposed to find out the producer's surplus. Okay, to find out the producer surplus, first what we need to do, we need to find out the equilibrium. So equilibrium occurs where demand is equal to supply, where quantity demanded is equal to supply. That is the point where these two curves meet. Okay, so at equilibrium what will happen? PD will be equal to PS, that is demand is equal to supply, because this is the demand function, this is the supply function. So equating them with each other, we get 3x square minus 20x plus 5, and we equate it with 15 plus 9x. Okay, so solving further, we have 3x square minus 20x, transpose it here, it becomes minus 9x. Then we have plus 5, transpose it here, it becomes negative 15, and we set it equal to 0. So here we get 3x square minus 29x. Then we have 5 minus 15, which is negative, rather negative 10, and we set it equal to 0. This is a quadratic function, and we will solve it using the use the quadratic formula here. Rather, here we have the coefficient of x square is, let us say it is a, it is 3. Coefficient of x is negative 29, which is b, and we have the constant term, which is negative 10. Using the quadratic formula, how do we use the quadratic formula? We know it. So x will be equal to, that will be equal to minus b plus minus b square minus 4 times a times c upon 2 times a. Okay, so having said that, let us put the values here. So we have x is equal to, so we have negative b means negative of, let us write it here, negative of minus 29. Then we have plus minus b square means negative 29 whole square. Then we have minus from the formula. Then we have 4 times a times c. So we have 4, the value of a is 3, and the c is here negative 10 upon 2a. 2 times the value of a is 3. So x will be equal to, so negative times negative is positive, we get 29 plus minus, now square of a negative number is always positive, so the square of 29, I calculated it, it came out to be 841, and this is here negative times negative is positive, so 4 3s are 12, 10s are 120. So here we have 120 upon 6. So we will get x will be equal to 29 plus minus, sum these two terms, two numbers rather, we get 961 upon 6, and which will be equal to 29. The square of 96, we have 961, its square will be equal to 3 3s are 9, then this gets doubled, so it becomes 6. So here we have 60, so 61 into 1 is 61, that means the square root of 961 is 31. So we get 31 upon 6. Okay, so after that, that gives us two values of x. That is either x is equal to 29 plus 31 upon 6, or x is equal to 29 minus 31 upon 6. Here we will get a negative number. 29 minus 31 is minus 3 upon 6. So quantity cannot be negative, so we can outrightly reject this negative quantity. That means quantity, equilibrium quantity will be equal to 29 plus 31 is 60 upon 6, which comes out to be 10. Okay, so we have found out the equilibrium quantity, which came out to be 10 here. Now we are supposed to find out the equilibrium price. Plug x is equal to 10 either in demand or supply function. Let's put it in the supply function. That will give us the equilibrium price here, that is 15 plus 9 times 10, so which comes out to be P will be equal to 15 plus 9 tens are 90 plus 15 is 105. Okay, so this is the equilibrium price, this is the equilibrium quantity. Okay, now I need to rub this all stuff to find out the consumer surplus. For that, let me rub this. So what we got after solving this, we got a price came out to be 105 and equilibrium quantity came out to be 10. So here we have 10. Now we are supposed to find out the producer surplus. So producer surplus is simply the difference between the amount a producer receives for a product and the minimum amount they would be willing to accept. Okay, graphically it is simply the area which is above the supply function and below the equilibrium price. So the area of this very region okay, so let me see if I have done it correctly. Okay, that's correct. So the area which is above the supply function or supply curve and below the equilibrium price gives us the producer surplus. Graphically it will be to find out the area of this very region. What we need to do, so producer surplus, let us denote by PS, is simply equal to, so first we need to find out the area of this rectangular box. So first we find out the area of this rectangular box. Okay, whole area. From this we subtract the area which is below the this very quadrilateral, that is this, and we will be left with the above triangular shaped curve. Okay, let us first find out if we can okay, we don't need we can solve it using two methods, either graphically. So we know the intercept of the supply function is 15, and let us see if we can solve it like this. So this is, since this is a what we call a right angle triangle, so it is, so producer surplus will be equal to the area of this very triangle. So we have why price, rather price is 105 here, sorry, 105. So and the difference, and this length is 105 minus 15, so 105 minus 15, which is base, into what is height is from 0 to 10 divided by 2. This is the area of a right angle triangle, that is 1 upon 2 into base into height. Okay, here base is, if we assume this is base and this is height, because we know it is at 10. So let us see if we can find it like this. So 105 minus 15 is 90 into 10 upon 2, we get 900 upon 2, which is equal to 450. Okay, we have the 450 in the options. Okay, it is very simple to solve it like this. Or we can use a lengthy method, rather, that is to use what we call the calculus, that is to use the integrals. So remember, where do we use the integrals? When we have non-linear, both rather one of the non-linear demand or supply function, or both are non-linear. Since our supply function was linear, we were supposed to solve it graphically. If we were told to find out the consumer surplus, we could not have solved it using the graphical method, by obvious reasons, because our demand function is non-linear. Okay, so in that case we would have to use what we call this definite integral method. So if we use the definite integral method, how could we have solved it? So I will not solve it, just to give you an idea. So first, the area of this very triangle, this very region will be equal to, so since so producer surplus, if we use the calculus here, so the area of this whole rectangle will be equal to price, which is price into quantity. So which is equal to price into quantity demanded, that is obviously the total revenue, minus then we need to find out the area of this very region. Okay, so it will be simply the definite integral from 0 to 10, so 0 to 10 times rather the definite integral from 0 to 10 of the supply function, that is 15 plus 9x. If we solve it like this, we will get again the same result as 450, but we are not supposed to find out here, because to save the space or time we can use the graphical method, because our supply function is linear. So why will we make it more difficult? Okay, the question is to find out the equilibrium level of output. If the consumption function is equal to 20 plus 0.8 y subscript d, where yd denotes the disposable income, investment is autonomous, which is here 50, government expenditure, which is autonomous, which is 20, and we are being told that we have the tax is equal to 10. We are supposed to find out the equilibrium level of output. Okay, so we know our total income should be equal to the consumption expenditure plus investment expenditure plus government spending. So we also know that consumption function is being given us as 20 plus 0.8. Now what is y subscript d? This is disposable income. Disposable income is simply equal to what we call the total income minus the taxes. Okay, so I guess here the taxes are lump sum. So we have y minus t plus we have investment, which is 50, plus government spending, which is 20. Solving further, so y will be equal to, so we get 20 plus 0.8, and t is being given us as 10 here, and let's write it here 10. So we will get here 0.8 times y minus 0.8 times 10 is 8, then we have plus 50 plus 20. Transpose this y here, so we get y minus 0.8 y nar lagnu huinen the ms had. So we have 20 plus 20 is 40, so 40 plus 50 is 90. 90 minus 8 is nar lagnu, and 90 minus 8 kodago, that's 82 I guess, sorry, which is 82. Subtract 0.8 y from y, we will get 0.2 y is equal to 82, or 2 upon 10 y is equal to 82. Y will be equal to 82. Transpose it here, it gets multiplied but reciprocated. So y will be equal to, so we get 2 1s are 2 5s are 10, 5 2s are 10, 5 8s are 40, which is 410 here. Okay, so the correct option should be 410. Here this shows the tax revenue. We don't have here the marginal tax rate. Then we would have the equation like this, y minus a small t times y. Okay, the question is to find out the elasticity of demand. If the demand function is being given us as x is equal to 25 minus 4p plus p square, where x is the quantity demanded, p is the price, then elasticity of demand for price is equal to 5 will be, options are given. We need to find out the correct option. So we have the demand function is x is equal to 25 minus 4p plus p square, and we are being told that price is equal to 5. Okay, we need to find out the elasticity of demand. So first we need to find out the quantity demanded when price is equal to 5. So plug p is equal to 5 here, so we will get x will be equal to 25 minus 4 times 5 plus 25 square, rather 5 square, which is 25, which gives us 25 minus, so we get 50, 25 plus 25 is 50. 4 5s are 20, so we will get 20. Okay, so which is equal to 20. Now we know that elasticity of demand is given by the change in the quantity demanded due to the change in the price into price upon the quantity demanded at that very price. So we need to find out the derivative dx upon dp. That is the change in the quantity demanded due to the change in the price. So taking derivative of this function with respect to p, derivative of a constant is 0. So derivative of p in the second term is 1. So we are left with minus 4 plus derivative of p square is 2p. This is our derivative. Now elasticity of demand will be dx upon dp, which is minus 4 plus 2 times p times p is being given us as 5 upon quantity demanded at that very price is 20. Okay, we also need to plug the value of p here, so e will be equal to so it is like this, minus 4 plus 2 into p is 20 into 5 upon 20. So we will get here elasticity will come out to be, so we have 20 minus 4. Yes, let me see if I have done it correctly or not. So we get 20, rather p is 5, sorry, p is 5, so we get 2 5s are 10 minus 4, which is 6. It's like this, so we get 2 5s are 10 minus 4 is 6 into 5 divided by 20. Rather it is 30 here. So we have 50 minus 20, which is 30. My mistake. So here we have 30. So we get 30 upon 30, which is equal to 1. So elasticity of demand is 1. That means if price increases by 1%, quantity demanded will decrease by 1%. It is in fact a rectangular hyperbolic demand function. Rectangular hyperbola, that is, we have this kind of demand function where the elasticity of demand is same. The question is to find out the marginal propensity to consume. What is the marginal propensity to consume in the consumption function where C is equal to 40 plus 0.75 Y subscripted? The options are being given. We need to find out the correct option. So C denotes the consumption, which is equal to 40. So 40 is our autonomous consumption when the level of disposable income is equal to 0. Okay, so this denotes the autonomous consumption. Plus 0.75, I will talk about it, times Y. What is Y? Y is our disposable income here. Okay. Now, what is marginal propensity to consume? Marginal propensity to consume is equal to the change in the consumption due to the change in the income. Okay, how much our consumption changes when there is 1 unit or 1% change in our income. That is the derivative of this function with respect to y. Derivative of a constant is 0, derivative of y is 1, so we are left with 0.75. In fact, 0.75 is our marginal propensity to consume. It simply tells us if our income increases by 1 unit or by 1% or 1 unit rather, consumption will increase by 0.75%. Okay, or let me put it in another way. So the incremental change in consumption due to the change in the income will be 0.75. Every additional dollar ROP, out of that 75% will be consumed. So the question is to find out the savings function from the consumption function. If consumption is equal to 40 plus 0.75y, C is the consumption, 0.75 denotes the marginal propensity to consume, 40 is the autonomous consumption when the level of income is 0. Here y is equal to income, rather it is income. We need to find out the savings function here. So we know that our total income is used for consumption and also for the savings purpose. That means y is equal to C plus S. Okay, so we have y will be equal to, consumption is being given the function like this, 40 plus 0.75 y plus we have S here. So solving for s, so s will be equal to, so we have y, then we have minus 0 point, or let us write it like this. So s will be equal to, let us transpose this here, it becomes negative 40. Then we have plus y minus 0.75y. That gives us savings will be equal to minus 40. So subtracting 0.75y from y, we will get as 0.25y. That will be the corresponding savings function. The question is, if marginal propensity to import is 0, what happens to the trade multiplier? Options are, it equals the ordinary trade multiplier, it is greater than ordinary multiplier, equal to 0, or less than what we call the ordinary multiplier. So in case of foreign trade multiplier, it is being given by, so let us denote it by M. F, it is equal to 1 divided by the marginal propensity to save plus marginal propensity to import. Now if MPI is equal to 0 in this equation, so our multiplier will be equal to 1 divided by 1, or rather MPS, marginal propensity to save, which is in fact our ordinary multiplier, which we write it in this fashion, that is 1 minus the marginal propensity to consume. Okay, so if MPI is equal to 0, trade multiplier becomes the ordinary multiplier. The question is to find out the Parsh's price index. Suppose the summation of P0 Q1 is equal to 450, summation of P1 Q1 is equal to 519, and summation of P1 Q0 is equal to 415.2. We need to find out the Parsh's price index. Okay, so Parsh's price index, is a consumer price index used to measure the change in the price and quantities of basket of goods and services. It is also called the fixed basket index. It calculates the cost of the specific basket of goods and services in the current period relative to the cost in the base period. That's Parsh's index is being given by, let us denote by P. It is simply equal to the summation of what we call the cost of baskets in the current period, that is P1 Q1, that is price in the current period, quantity in the current period. It is summation, the summation of these baskets, which is P1 Q1 upon relative to the cost in the base period. So base period is P0 Q1, that is P0 Q1. So which will be equal to, so we are being given P1 Q1 is equal to 519 upon P0 Q1, it is 450, which will be equal to, when we solve it will come out to be, so we multiply it by 100, so here we also multiply it by 100, so it will come out to be 1.25 into 100, which comes out to be 125. So this will be the Parsh's price index. In case of Lespier's price index, that is being given by, that is summation of P1 Q0 upon summation of what we call P0 Q0. Okay, and then we have the Fisher's index. So Fisher's index is simply the geometric mean of L and P. So I will not go into the detail. The question is to find out the correlation coefficient. If covariance of two variables x and y is equal to 10, variance of x is 16, variance of y is 9, find the coefficient of correlation. Options are being given, we need to find out the correct option. So correlation coefficient is being given by, that is equal to the covariance of x and y upon under root of variance of x times variance of y. So covariance is here 10 divided by, we have here variance of x is 16, so let us expand it like this, So here we have 9, so we will get 10 divided by 16 is 4, under root of 16 is 4, and under root of 9 is 3. So we get here 10 upon 4 3s are 12. Solving it further, so we have this becomes 5 upon 6. So we have 5 here, then we have 6 here. So here we have point, here we have 0. So we get 6 8s are 48 to our left, then we have 0. 6 3s are 18. So we get 0.83. So here we have one option, 0.83. So this should be the correct option. The question is about Hawking-Simons condition. The correct Hawking-Simons condition is, options are being given, we need to find out the correct option. Okay, so by Hawking-Simons condition, it is used in input-output analysis. Okay, so what is I? I is the identity matrix minus A denotes the what we call the technology matrix or input-output matrix. Now the Hawking-Simons condition says the determinant of this, when we subtract the technology matrix from the identity matrix, and when we take the determinant of that very matrix, it should be positive. Okay, so this ensures the viability of the system. Second is, and let me show it with an example here. Let us suppose we have the technology matrix is 0.4, 0.7, 0.1, let us say 0.6. Then we have and I minus A will be equal to then, and let's take the identity matrix as 1 0 0 1. So in this case what happens, we have I minus A. So I minus A will be a matrix that will be 1 0 0 1. From this we subtract this 0.4, 0.7, 0.1, 0.6, this matrix is. So I minus A will be equal to, so 1 minus 0.4 is 0. When we subtract 0.4 from 1, we get 0.6. Here we get 0 minus 0.1 is negative 0.1. Then we have 0, here it is minus 0.7. Here we get 1 minus 0.6, which is 0.4. Okay, this is the matrix here. Now when we take the determinant of this I minus A, it will be equal to, we multiply these two terms first. So we have 6 into 4 is 24. So we get 0.24. Then we subtract and multiply these two. So here we get 0.7 into 0.1. What will we get? Okay, so we have 7 upon 10 into 1 upon 10. So we get 7 upon 100. So we get here 0. So what about 0.6? So we have 6 upon 10 into 1 upon 10. So we get 6 upon 100, I guess. Okay, so we have here rather 4. Okay, it is perfect. So let us subtract this. So it is 0.07 rather here. So here you can see it is I minus A is positive. Okay, it satisfies the viability condition. Second condition is that is the what we call, we should have principal diagonal elements. These are called the principal diagonal elements, and that should be positive. Here we got it positive, it is also positive. So these are the two what we call the conditions. First is that is we should get the positive determinant of this I minus A matrix, and the principal diagonal elements of I minus A should be positive. The question is, what will be the probability of getting more than number 2 by throwing an ordinary die? Options are being given, we need to find out the correct option. So in a die we know there are 6 faces numbered from 1 to 6. Okay, so we have 1 2 3 4 5 6. The question tells us what is the probability of getting a number more than 2. So this is 1 which is less than 2. More than 2 means we don't need to find out these. So the number of favorable outcomes are 3, 4, 5, 6. So we have 1, 2, 3, 4. So probability of getting a number which is greater than 2 will be equal to the number of favorable events, which are here 1, 2, 3, 4, upon total number of events, possible events, which is here 6, which comes out to be 2 upon 3 in this case. The question is to find out the arithmetic mean. If mode is equal to 27.78, median is equal to 27.73, then arithmetic mean is, options are being given. We need to find out the correct option. So we know the relationship between mean, mode and median is being given by, that is mode is equal to 3 times median minus 2 times mean. So you just need to plug the value of mean and mode, rather the value of median and mode, to get the value of mean. The question is to find out the output that maximizes the profit of the monopolist. If the demand function of a monopolist is P is equal to 100 minus 2Q, P is the price, Q is the quantity, and cost function is C is equal to 50 plus 20Q, then the quantity of output for the profit maximization will be, options are being given. We need to find out the correct option. So we are here, we have P is equal to 100 minus 2Q. This is the demand function. Cost function is being given as 50 plus 20Q. Profit maximization for monopolist, as we know, we equate the marginal revenue with the marginal cost. Graphically, if I draw the graph, so what we are supposed to do, we have the quantity on the horizontal axis, price on the vertical axis. We have downward sloping demand function. Okay. Then we also, this is our demand function, average revenue function. Then we need to find out the marginal revenue function. Okay, if this is our average revenue function, we are supposed to find out the marginal revenue function for the monopolist. So we need to find out the marginal revenue, and also we need to find out the marginal cost for profit maximization. And let us, to find out the marginal revenue, first we need to find out the total revenue, which is equal to price into output. So P is this 100 minus 2Q. To this we multiply by Q. That gives us total revenue as 100Q minus 2Q square. Now marginal revenue will be the derivative of the total revenue function with respect to output. That is the change in the total revenue due to the change in the output. Derivative, so differentiating this with respect to Q, derivative of Q is 1, we are left with 100 minus derivative of Q square is 2Q, so 2 into 2 is 4Q. This is our marginal revenue. What about marginal cost? Marginal cost is simply the change in the total cost due to the change in the output. That is the derivative of this function with respect to Q. Derivative of a constant, we know it is 0, and derivative of Q in the second term is 1, we are left with 20. Now equating marginal revenue with the marginal cost, we get, which implies 100 minus 4Q will be equal to 20, or 4Q will be equal to 100 minus 20, which is equal to 80, which implies Q will be equal to 80 upon 4, which is equal to 20, I guess. Okay, so if this marginal revenue, so marginal cost is here 20, let us suppose. So this, at this point where quantity demanded is equal to 20, that will maximize the profit of the monopolist.